One of the questions that comes up in the forums every so often is, it goes along the lines of, I've built a North Pole style sign using a Pi and a ColorLight, and I'd like to put some pixels in the bulb on the top of the pole, or I'd like to run some pixels around the outside of the panels, something like that. Can I do it straight off the Pi? Well, the simple answer is yes, you can. The Pi, as we well know, runs on 5 volts. Pixels, if you use 5 volts, then they'll run just fine. There are some caveats though. The first one is, yes, of course, the pixels run 5 volts. Can the Pi supply enough power? Well, if you're just doing a few pixels in the top of the bulb on like a North Pole sign, then you're probably going to be fine. You can run, you can tap 5 volts directly off the GPIO on the Pi, and for that small amount, you're only going to be drawing around half an amp. So if we stick with the rule of thumb of 0.06 amps per pixel, I've got 9 in this little string here that I found. So that gives me 0.54 amps at 5 volts. Half an amp shouldn't be any issue. There's a little bit of give and take on the Pi power supply. We're not going to be maxing it out, so it's not going to need all the juice that's available, so we should be fine. Any more than that, and you want to look at powering the pixels by a method other than the GPIO. So if you're already running panels and the Pi, then you've probably got a Meanwell or something like that already set up in your cabinet, so you can tap the 5 volts from there. If you do that, make sure you connect both the ground and the data line to the Pi, and also the ground can then go back to your power supply as well. So the ground needs to go both directions to ensure a level ground, a good level playing field, to give the data signal a reference voltage. So picturing the scene here, I've just built a North Pole sign. The panels are in, they're being run by a ColorLight, and I just want to stick these pixels into the globe at the top to make that go in time as well. Now I could of course buy a Pi hat, just plug it straight on top. That will work just fine when you're running a ColorLight as well. You could alternatively have not gone with the ColorLight for a small one, and you could use something like this Hanson MFC hat. It's got outputs for pixels, for panels, DMX if you want it. It's got a nice little OLED so you can see what's going on, and a real-time clock, so it can do its own thing to time. Once it's set up and running, it doesn't need an internet connection, then it will just know what it's doing. Comes in at £30 and is a good value piece for building a little sign like that, if you haven't already gone the ColorLight route. So for this setup we have, so we're going to connect straight to the GPIO. Now the other gotcha, as well as power, is the data line. Now the Raspberry Pi, although it takes a 5 volt feed to power it, the data lines on the GPIO only run at 3 volts 3. Now a Pixel expects its data line to run at 5 volts. So can we do it? Well, yes. So 3 volts 3 being greater than 2.5 volts, which is halfway between ground or 0 and 5. 3 volts 3 being closer to 5 than it is to 0, the pixels will see it as a good data signal. But it doesn't take very much at all for that 3 volts 3 signal, a little bit of loss on a joint, on a little bit of cable, that 3 volt 3 is soon going to drop to 2.5 volts or less. And once it gets down to close to that, it's going to be difficult for the pixel to distinguish what is a positive, a high on the data line, and what is a low. So you're going to be limited on your cable length from the GPIO to your first pixel. Anything more than probably 3 feet, about a meter, and you're going to start getting issues. So you need to keep this distance to the first pixel really short. Now let's not forget that the pixels regenerate the signal. So this one will take the signal, strip the bit off it needs for itself, and then send the rest out. So this pixel will do the voltage increase up to 5 volts going forwards. So there's no reason why you can't have a null pixel near the Pi and then run a slightly longer cable out to pixel number 2 and so on. Right, enough of the scaremongering. Let's get on and show you how to do this. Now I have got a trusty pin out, and I'll put one onto the page here or here somewhere. I always find it useful, even though I know which pins I'm going to use, just to have a ready reckoner, because if you get your pins wrong, give it juice, you can quite easily let the magic smoke out, and then you need to go shopping for a new Pi or pixels or both. So don't do that. I have done it, and it wasn't a pretty sight. Raspberry Pis don't like accidentally getting 12 volts on a GPIO, as I found out late one night while I was trying to finish a project. So let's go for it. So looking at the pixels, I've just added a little chock block connector to 3 DuPont plugs, just to make it nice and easy to plug onto the Pi. So my red for power needs to go onto 5 volts. So I'm just going to put that on the top right hand corner up here. There we go. Ground in this case is coming through as yellow, but after it's blue on the pixels, and then I've got a yellow DuPont on the end of that. So I'm going to skip one. So that's gone on to pin 2. This one is going to go on to pin 6. There we go, and there was a little flicker of light as the pixels got power, but the Pi hasn't rebooted or anything. I'm taking a risk and doing this live. You may or may not want to do that. And then data for this, the Pi has 2 PWM pulse width modulation ports that are available for chucking pixel data out of, and they are ports 12 and 35, otherwise known as BCM 18 and BCM 19. I'm going to use BCM 18 because it's up near the other ones here. So I've got 5 volts, I've got space, I've got ground, I've got 2 spaces, and then I've got BCM 18. So I can plug that straight into BCM 18. There we go. And our pixels are now plugged in directly into our Pi. So let's make them work and see if we can get some blinky flashy. Looking at the PC now, I see that FPP is all up and running, and if I go to the input output setup, outputs, I'm going to go straight for the LED panels tab, just to demonstrate that we're set up here for a ColorLight card. I've obviously not completed the layout, but it's set for 2 wide, 2 high, going out of a ColorLight with a total of 2048 pixels. So that's running 4 P10s. Now if we navigate to the Pi Pixel Strings tab, we can simply add an output. We'll look for the WS281X. That's your regular pixels. There we go. And you can see it gives us 2 output opportunities. Now port 1 is BCM 18, as I referred to earlier, and port 2 is BCM 19. So I've connected onto 18, so we need to configure this top line for our pixels. Now our LED panels channel count is 6144, and we're starting at channel 1. So my pixel strings need to start at 6145. So just taking the next available channel after the ColorLight. The number of pixels, we've got 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pixels in one group. There we go, and that's set. All good, done. So I'll save that. Now I'm just going to make a note that I'm starting at 6145, 61 and ending at 6171. There we are. Restart FPPD. That's restarted. And now if I go to status, display testing, there it is. Okay, so I'm now going to test my pixels, so I need to just change my numbers in here to 6. There we are, 6145 to 6171. And if I now enable test mode, there we are. We have blinky flashy pixels. So there you are. That's demonstrated that you can run some 5-volt pixels directly off the GPIO on the Pi. Particularly useful if you're running the ColorLight, obviously, but you could use it for your regular strings. As long as you keep that distance short, then it will work just fine. Hope that was useful. Once it's configured in FPP and you've got your channel numbers, you can of course set them up in xLights as normal. I would use DDP at this point. You just go and do an explore with DDP and it will find the Pi and the two outputs, the one for the panels and the one for the pixels. Have fun, enjoy, and see you soon.